All right, let's wait. Hello, everyone. So today we're showing you a little bit of our CFD analysis on a ship. And so to start off, we're going to take you and show you our actual geometry. So as you can see at the top left here, we have our imported geometry where we took off somewhere. And with that geometry, the geometry was just the ship by itself, as you can see. So after doing that, after importing our geometry, we put an enclosure around our entire ship. If I were to take off the section plane, and then with that, with the enclosure around it, speaking of the enclosure, there's are the dimensions for the enclosure. And afterwards, we did a Boolean with the target body and the tool bodies. The target body being the actual ship, and the tool body being the enclosure. And then after that, we made it where we cut it in half for the section plane with the section plane. That way we could see the boat from the right angle and use the enclosure as an inlet and an outlet, and an atmosphere, and then a wall. So moving on from the actual geometry, we move on to our mesh. So with our mesh, you can see here we have our solid, and then our mesh, all we did was use one thing of body sizing, and we used it on the entire geometry itself, and that includes the actual enclosure and the boat. So as you can see, we changed the element size, and we made it 0.25, and we turned on capture curvature. Afterwards, we named the selections on the enclosure and the ship. Here you have the inlet, you have the outlet, you have the wall, which is the other side of the enclosure, you have the ATM, which is the top, you have the symmetry, which is the side where the ship is on, and then you have the actual ship itself. So that is our meshing. As you can see, our boat meshing is really fine in the corners compared to the actual enclosure. It's tighter, it's more defined in these areas right here. Now, that was our mesh. We will move on to our solution and setup now. Okay, so to start off, we put in gravity. We added gravity, did not change anything here, and we set the gravity to negative 9.81 meters per second squared. So afterwards, we changed our models. We did volume of fluid, and we changed it to an open channel flow implicit. We left the volume cutoff as 1 times 10 to the negative 6, and we turned on implicit body force. We left the Eulerian phases at 2, and we changed this to volume of fluid. And then we'll go back to this. We changed our viscous to K omega. We changed it to SST, and we turned on production limiter. These are our stats and our data for the K omega. Now, going down to the materials, we will soon go back to the multi-phase. But first, we have to go and show you our materials. So as you can see, we changed fluid and we added water liquid. And these are our stats and our data. So going back, when you go to multi-phase, you click on phases, and you make a primary phase as air, which is going through the inlet over here. And then the secondary phase will be your water and liquid. Now, we did not mess with anything in the cell zone conditions. All our work is done, or most of our work is done, in the boundary conditions. So, our ATM, which is the top, we left it as a wall, as you can see. Our inlet at first was a velocity inlet, and we changed it to pressure inlet. And we also made it a mixture. Now, when you edit this, we left nothing, or we changed nothing on the momentum. We did all our work in the multi-phase. This is the secondary phase for inlet, and we made it water. It's an open channel. That's what you have to turn on open channel in order to access this multi-phase section. At first, when we did this simulation, we had the free surface level at 1. And when you did it, the water was at the midway point of the boat, and the boat was practically a submarine. And then so we changed it. We reran the simulation, changed the free surface level to 0.25, and we made the velocity magnitude 10 meters per second, and the bottom level is -5. Now, our outlet, we made it a pressure outlet with a mixture phase. And again, we did not touch anything on the momentum. All our work was done in the multi-phase. Same thing here, free surface level, 0.25. It was 1, but we changed it, like I said. And the bottom level was -5. For our ship, we left it as a wall. You need to leave it as a stationary wall because it will not be moving. Nothing else was changed in this section. For our symmetry, we changed it and left it to symmetry. And there was nothing to change on this. The wall, same thing. Stationary wall, nothing was changed. Now, for our report, we made a report with drag force, changed our force vector. Our force vector started out as 1, 0, 0, and we changed it to 0, 0, 1. You write drag force, and you turn on drag force, not drag coefficient. You make it report, plot, and report file. And you set the zone to the ship only, not the ATM, or nor the wall solid. That is important when you get your data. For the monitors, the residual monitors, we did not change anything, and we left everything as 0.001 on all monitors. For initialization, we left it as hybrid initialization and did it from the inlet and make sure it's at flat, and then you initialize. And then after that, you would click on animation playback after you initialize it. Now we wait for it to initialize. We can cut this part. So as you can see, we already have stuff downloaded, and you would want to clear it, or we will clear it, or we will. Okay, so our convergence is done, and we are going to cancel because we do not want to clear the animation object history that already exists for us to show you. So as you can see, we did ours for velocity vector. We named all of them. They would just be animation 1, animation 2, animation 3, animation 4. But we did one for our turbulence, our velocity vector, our pressure, and our velocity. This would be a velocity contour, not a velocity vector. These are all contours, and this is our only vector that we did. So now, afterwards, you would go here, go to graphics, and make your contours before you run your calculation. Now, your contours, at first one was our main one. This was our phase. As you can see, this is the water level. This is the air. This is our ship, of course. Next, you have your static pressure. As you can see, the water is more dense at the bottom. As it gets to the top, it becomes less dense. For our turbulence, it looks almost the same as the volumetric phase, but it shows the turbulence when the water as it's moving. Next, you have our velocity magnitude. And as the boat moves, when you will see from the animations that we will show you, you'll see that it moves and some of the back end will move as well. Next, this one right here was a one that we tried and tested. It did not work out. This is the one that we wanted to show you. So for this one, we did make sure you set it from 3D arrow to arrow. We're only showing our ship in symmetry. Remember that for all the contours. And as you zoom in, you can see all these arrows pointing back, going to the back of the boat, hitting the tip of the boat, going over the boat.
Now switching off, this is Jonathan Avarenga. The next start I'm gonna show is the plots and is our plots and our animations. So I'm gonna show the animations or the solution that we have. I'm gonna let this load up. So while that loads up, one of the animations that I want to show is the velocity. So like Logan was saying, we're able to see as the inlet of the flow and the water come, we're able to see where we have where our velocity changes based on where it hits. So at like at the tip, we have a change of velocity because the velocity changes at the top of the ship as well. This is all where we have a smaller velocity because this is where it's causing this is where our drag and this is where our where we lose for aerodynamics. Towards the end of the ship right here, this is where we have a high point in drag. So this is what also causes the ship to propel. We also have a high drag right here, or a high velocity right here. That's the movement of the water as the ship moves. Cutting into this, this shows the volume of fraction. So this kind of shows the two phases more in depth of the water and the air. This was the first mess up that we had. So you can see this was kind of in the middle, and so we had to move this down. The next picture we have is the velocity magnitude. So you can kind of see the airflow as the boat is moving, as the water hits it and the air hits it. So you can kind of see where you have a lower velocity. Talking more about the velocity magnitude, this is kind of the airflow that goes into it. So you can kind of see at the tip of the boat where it hits, you can kind of see the the displacement of the velocity towards the end of the boat as well. You can kind of see that drag that happens. You can kind of see that it kind of creates like a tail movement. And at the ship right here, at different places where we have a lower velocity magnitude, you can kind of see the drag that happens. Right here, this red spot is what the motor would create in the water. So you have a high velocity magnitude from there. Because of the boat is blocking it at these points right here. This last graph is our drag graph. So you can see we start with a high drag coefficient. Um, this is kind of in part the ship is first taking sail or taken off, and so it has a higher drag. And then as the ship continues, the drag will go down because the ship is more streamlined and it has less of a drag force setting across it. So that's the end of our presentation for CFD. Thank you for tuning in.